In this video, we're going to look at solving trig equations. I've got two equations up here. Here's one equation. This one you'll have seen before. It's not a trig equation because there's no trig function in it. However, here, this is a trig equation because we've got some trig expressions in here. In this case, we've got sine theta. Let's go back and review this one. If we were solving this if we were solving this equation here, we would want to isolate x. So we would minus 5x from both sides, and we would get 2x minus 4 equals 6, because these would cancel out. And then, of course, we'd add 4 to both sides. And so now we've got all the x's on the left side. We've got our constant terms on the right side. And the last step was to divide by 2 so that we isolated x. We got x equals 5. Well, we would do the same thing in this trig expression. So we want to get sine thetas all together. So to isolate sine theta, I'm going to minus 3 of them off this side, so they're gone. Got a minus 3 from this side. So if I have 5 sine thetas and I take away 3 sine thetas, I would be left with 2 sine thetas. And now we can add 2 to both sides to get rid of the constant terms. And negative 1 plus 2 is positive 1. And finally, just like here, we'll divide by 2 the coefficient of sine theta. And we get sine theta equals 1/2. Now we haven't actually solved for theta here yet. We've got to figure out what the angle is. So we're not done yet, but we've got it so that sine theta equals 1/2. And now what we can do is we can go to our circle here, our unit circle. So we know this is 0, we know this is pi over 2, pi, 3 pi over 2, and 2 pi. And so let's say that we want to find all of the angles between 0 and 2 pi. So we can look at our ratio here. Sine is positive. And you remember our little shortcut for remembering all students take calculus. So we're looking for where sine is positive. Sine would then be positive in quadrant 1. I'm just going to draw an angle there in quadrant 1. Boom. And sine is also positive in quadrant 2. So I know now that since our sine ratio is positive, that I'm going to find one answer between 0 and pi over 2, and another answer between pi over 2 and pi. So we can look at this ratio and see that this comes from our special triangle, the 1, 2, root 3 triangle, where this angle was pi over 3 and this angle is pi over 6. And the triangle is going to find for us our little reference angle in here, theta r, our reference angle. So what is the angle, when we take the sine of it, that gives us a ratio of 1/2? Well, that's going to be sine of pi over 6, because sine is opposite over hypotenuse. So I now know that my little reference angles in here are pi over 6. And since I'm measuring from 0 to 2 pi, one solution is going to be theta is equal to pi over 6. That was this one. My second solution is going to be this one here. I'll call this answer 1, angle 1. My second solution then would be all the way around here is pi. So if I went all the way to here, which is pi, and backed up pi over 6, so that would be pi minus pi over 6. And getting common denominators and subtracting, that's 6 pi over 6 minus 1 pi over 6, which is 5 pi over 6. So my angles for theta would be pi over 6 and 5 pi over 6. And now I've solved this trig equation for sine theta equals 1/2, and I've given my two angles between 0 and 2 pi. I'd have this one here, and I'd have this one here. Let's look at this example here. Solve 5 cos theta plus the square root of 3 equals 3 cos theta. And I want all the angles again between 0 and 2 pi. So we're going to need to isolate cos theta. So let's minus 3 cos theta here, minus 3 cos theta here. So that's 2 cos theta plus the square root of 3 equals 0. Then we could minus root 3 and finally we can divide by 2 to isolate cos theta. So that part's very similar to solving equations from the past. Now that we're at this step, we need to deal with this cosine theta piece. So here's where the trig comes in. So we need to find out where is cosine negative. Well, cosine's positive here, sine's positive here, so we must have one answer in this quadrant. And tan is positive here, so cosine must be negative here, and cosine's positive there. We have a negative ratio, so we won't have an answer there. Now we just got to figure out what these little reference angles are, and we will need our triangle. Once again, it's the 1, 2, root 3 triangle, where that angle is pi over 3, pi over 6. So you need to have these triangles memorized. And we're looking for the cosine of something that is root 3 over 2. That appears to be pi over 6 here. Cosine is adjacent over hypotenuse. So our little reference angle in here is going to be pi over 6. And we will want this angle. And we will want this angle. So we'll call that first one here theta 1. How would I figure that out? Well, if I know this little part in here is pi over 6, and this all the way to here is to pi, theta 1 is going to be pi minus pi over 6, which would be 5 pi over 6 once we get common denominators and subtract. And our second answer would be this one, which is all the way to pi plus some pi over 6. And so this would be 6 pi over 6 plus 1 pi over 6, which is 7 pi over 6. So those would be our two angles for theta that would satisfy this equation that we were given here. A couple of things are different in this example. Here we have a quadratic trig equation because there's a sine squared theta. And instead of going from 0 to 2 pi, we want to find the angles between minus pi and pi. Well, if you look at this equation, 2 sine squared theta minus sine theta minus 1, 0, it's really just like this equation that you would have solved before in your math experience. So if we kind of let sine theta equal x, then this would read 2x squared minus x minus 1. Sine squared theta, when you see this here, that just means sine theta times sine theta. So sine squared theta means we have a product of 2 sine thetas there. But if you were doing this question here, you would simply factor this equation. And once you've factored it, let me just check this. 2x times x is 2x squared plus 2x minus 1x. Oh, that's not negative 1. So I need to make that plus and this a negative. So 2x times x is 2x squared. 2x times minus 1 is minus 2x. Plus 1 times x is plus 1x. So that's going to combine to give me the minus x term there. And 1 times minus 1 is minus 1. So now I'd have it factored. And so I can say, okay, 2x plus 1 needs to equal 0, or this second factor needs to equal 0. And so I can say 2x equals minus 1, and divide by 2. I have x is negative 1/2. Or here, isolating for x, I get x equals 1. So you've done those kind of equations before. So this is actually done the exact same way. You would factor this quadratic, and we would have 2 sine theta plus 1 times sine theta minus 1 equals 0. And you should always double check when you multiply it out. Do we get 2 sine squared theta? Yes. Do we get minus sine theta? There would be minus 2 sine theta plus 1. That's minus 1 sine theta. And do we get negative 1? Yes, 1 times minus 1 is minus 1. And so now that we have this factor times this factor equals 0, we can take our first factor, set it equal to 0, and take our second factor, set it equal to 0, and now solve for sine theta. So bring that over there. Now divide by 2. So we get sine theta is negative 1/2, or sine theta equals 1. So just like we had over here, except it's sine theta instead of x. Now we actually have 2 questions we've got to do. So where is sine theta equal to negative 1/2? Well, let's do this one first. Sine is negative, let's see, sine would be negative in this quadrant and in this quadrant. And we would need to go to our special triangle and get our reference angle. It looks like pi over 6 again here. So those are our little reference angles in there, pi over 6. Now, in the other questions, we went from 0 to 2 pi. So we went this way from 0 all the way around to 2 pi. Here we don't have that. We can go from negative pi to pi. So if I start at 0, I can go from here to pi. Do I hit any of the angles I want? No, I don't. There's no angles in there that satisfy this restriction on the domain. But I can go as far down as negative pi. So I can start here and go, whoop, I just hit an angle right there. So what is that angle? Well, going this direction we know is a negative direction. So we know this reference angle here is pi over 6. So one answer will be negative pi over 6. That was this one. And whoop, there's another one. That's our second angle. We know all the way around to here is negative pi. But we've got to back up pi over 6. So from here is negative pi, but we've got to add. Remember when we go back this way, that's plus. So negative pi plus pi over 6, which is negative 6 pi over 6 plus 1 pi over 6. So we would get negative 5 pi over 6. So far we have 2 answers. Now, and we've done this one, now we need to look at sine theta equals 1. Well, sine theta equals 1. This is a special ratio. Sine theta is equal to 1. And let's see, here's 0, here's pi over 2, here's 3 pi over 2, and here's 2 pi. So we know that sine theta equals 1 when we have an angle theta equal to pi over 2. So sine theta equals 1 when theta is equal to pi over 2, which is right here. And so that is within our limits of 0 to pi, and sine theta is not equal to 1 at all in here because sine is negative in both those quadrants. So we don't have any angles from 0 to negative pi, but we'll get our one answer right here at pi over 2 when we go from 0 to pi. So we have 3 solutions then for this equation. Negative pi over 6, negative 5 pi over 6, and pi over 2 would be 3 angles for theta that would satisfy this equation, where those angles are between negative pi and pi. Let's look at this example now. Here's another trig equation. This time I threw a reciprocal trig, so I've got secant in there. And this time I want to give the general solution. This means I don't want just the angles between 0 and 2 pi or negative pi and pi. I want all the angles, an expression for all of the solutions. And to make it different, I said let's give the angles in degrees. All right, so same process here. We need to isolate our trig expression. So we're going to minus secant theta from this side. So if I have 2 secant thetas and I take away the 1 secant theta, I'm down with 1 secant theta minus root 2 equals 0. And now I can add root 2 to both sides, and I get this. Now, one of the things that we can do with the secants and the cosecants and the cotangents is we can change the secant, because secant is a reciprocal of cosine. I can call secant theta 1 over cosine theta. Right, so secant theta is the same thing as 1 over cosine theta. Now if I decide to take the reciprocal of the left side, I'm going to take the reciprocal of the right side. So I flipped this around here, it's just cosine. I flipped that around there, instead of root 2 over 1, it's 1 over root 2. So then it's the same process here, except now we're dealing with the 1, 1, root 2 triangle. And we're in degrees, so instead of pi over 4, I'm going to put the 45 degrees in. And the cosine of 45 degrees is 1 over root 2. So cosine is positive. We have a positive ratio here, so cosine is positive here and here. And I've just determined that my little reference angle here is 45 degrees. So my first angle is going to be this one. So we'll say theta 1 is 45 degrees. Now we know that if we were to take this angle 45 and find some coterminal angles, I could just add any multiple of 360 degrees. Every time I keep spinning around here 360 degrees, I keep hitting that same terminal arm. So this would be my general solution, 45 degrees plus any multiple of 360. I'm going to end up in the same spot. And we'll just tell people that n is an integer. So this n here means you can add 1 360 or 2 360, or you could back up minus 1 360 minus 2 multiples of 360. So n's a number like integers. Integers are like plus or minus 1, plus or minus 2, oops, well 0 I guess 2, plus or minus 1, plus or minus 2, plus or minus 3, and so on. My second angle, well, if I started here and went all the way around, this would be the same thing as going 360 degrees. 360 would be all the way around minus the 45. So that's 315 degrees. So my second angle is 315 degrees, again, plus any multiple of 360. I could keep spinning this thing around, keep going around, keep going around. Again, where n is an integer. So whenever it says a general solution, we'll be adding all the coterminal angles to our answers so that we're giving all the solutions. In this final example, we have tan squared x minus 2 tan, let's try that again. We have tan squared x minus 2 tan x minus 8 equals 0. And we are just going to find the ones between 0 and 2 pi. So maybe you're wondering how this is different. Well, you'll see. But every trig equation is done the same way. We need to isolate tan x. So this is a quadratic. So quadratic functions, we got to factor these ones. So if we got to find two numbers that multiply to negative 8 and add to minus 2. So that should be negative 4 and 2. So negative 4 and 2. Again, every time you factor, always multiply it out and make sure you get this line above. So I'm going to do that. Tan x times tan x, whoops, write the x there. Tan x times tan x is tan squared x. Tan x times 2 is 2 tan x. Then minus 4 tan x would be minus 2 tan x when you put those together. And then negative 4 times positive 2 is negative 8. So we are good. Now, we got to take each factor and set it equal to 0. And isolate tan x. So tan x equals 4 when you bring that over here, and tan x equals minus 2 when we bring that over here. So here's where it gets a little bit different, because we have two triangles, this one and this one. But neither of these triangles will give us a tangent ratio of 4. There's no 4s in these triangles at all. And a tan ratio of minus 2 is not going to work, because tan needs to be opposite over adjacent, and this is a hypotenuse. So our triangles are simply not going to work. Instead, we're going to need to use a scientific calculator to figure out what these answers are. So we know that tan is positive here, so we would be able to find an answer in this quadrant and one in this quadrant. And for the second part here, tan x is negative 2, tan would be negative in this quadrant because sine is positive, and it would be negative in this quadrant because cosine is positive. So I popped my calculator up on the screen here, and since we're trying to find the answers in radians here, I know that because it wants x between 0 and 2 pi, so I'm in radians. I'm going to make sure that my calculator is set up in radians. So under angle here, I've got radians, so that's good. So now to find x, I need to go, x would equal the inverse tan, if I'm isolating x, the inverse tan of 4. So that's what we're going to do here, is go inverse tan of 4 on the calculator. And it's not going to give us an exact value. It's going to give us an approximation here. So I'm going to say that the x is 1.3258. I'm going to go to 4 decimal places here, 1.3258. And your calculator doesn't necessarily give you reference angles. It gives you the angle that's closest to 0. So that would be this angle here, 1.3258, which does end up being our reference angle. And so then we would know that this little part over here would also be 1.3258. So now if I want to find my angles between 0 and 2 pi, one would be 1.3258, and so we'll call that x1. x2 is going to be pi plus 1.3258, which is, I'll go answer plus pi, 4.4674, 4.4674. Okay, and so there's two answers accurate in this case to 4 decimal places. Notice I didn't do any rounding of anything until the final answer. And then if it wants just to 2 decimal places, I could write 1.33 and 4.47 if it was to 2 decimal places. Now let's look at this one. So our second one here, we would want to take the inverse tan of minus 2. So we go to our calculator and inverse tan of minus 2. Okay, so I mentioned before that the calculator is going to find us the closest angle to 0. And so it looked and found that one, and it looked and found this one. But this one's closer to 0, so it's given us obviously a negative angle because this is negative going this way. So 1.1071, 1.1071. That would be that angle there because it was negative. So then I know that this must also be 1.1071. We don't want any negative angles because we want the angles from 0 to 2 pi. So we're starting here and we're going this way. So a third solution would be this one, which I know will be pi minus 1.1071. So pi minus the answer. so 4.2487. So there would be one answer accurate to 4 decimal places. And then our other answer is going to be this one, which we can go all the way around to 2 pi and minus that 1.1071. I'm just going to go the inverse tan again of minus 2 just to get that answer up there. And so now I can go 2 pi. In this case, I'm going to go plus this answer because the answer is given already as negative. So that's 2 pi minus the 1.1071, which is 5.1760. Is that what it was? I can't remember now. 5.1760. Yeah. So there's, we got 4 solutions, x1, x2, x3, and x4. So if your ratio, when you're solving these trig equations, come out to something that you don't have in your triangle, then you'll be using the inverse tan or inverse sine or cosine, depending on what your function is, to determine what your reference angles are from what the calculator has given you. So that's solving trig equations.